In the deep, humid twilight of the rainforest floor, a small creature stirs. A world of damp earth, decaying leaves, the intricate lattice of roots and fallen branches. Here, under the soft glow of filtered moonlight, the Hercules beetle begins its nightly work. Its shell, a polished armor of mottled greens and blacks. It catches the faint light with an oily sheen. It is small, often no longer than a human finger. Yet it possesses a strength that defies its delicate size. This is nature's true strongman, a quiet titan of the undergrowth. It moves with deliberate, powerful grace through its miniature kingdom. Scientists, with their meticulous methods and precise instruments, have sought to quantify the incredible power of this creature. Their findings are staggering. The Hercules beetle can lift an object weighing up to 850 times its own body weight. Let that number settle for a moment. 850 times. It is a figure that feels abstract, almost mythological, until we attempt to translate it into a scale we can comprehend. It is a multiplier that places the beetle in a league of its own, a champion of power-to-weight ratio that leaves most other creatures far behind in the dust. To truly grasp the magnitude of this strength, consider a human equivalent. Imagine an average man, weighing perhaps 180 pounds, or about 80 kilograms. For this man to match the beetle's relative strength, he would need to lift an object weighing over 150,000 pounds, or nearly 70,000 kilograms. This is not the weight of a car or even a large truck. This is the weight of a modern battle tank, a colossal machine of steel and firepower. It is a weight so immense that the very idea of a single person lifting it is the stuff of comic books and legends. What could this small beetle possibly be doing that requires such Herculean effort? To understand the beetle's power, we must look closer. We must slow down time, magnify its every movement, using macro lenses, using high-speed cameras. We can transform its seemingly simple actions into a cinematic ballet of mechanical precision. Each step is a calculated placement of support. The 6 legs, jointed, bristling with tiny hairs, extend and retract with deliberate force. They are establishing a foundation, creating a stable platform. The world of the beetle becomes a landscape of immense forces and delicate balances. The true spectacle begins when the beetle decides to push or lift. Its body angles downward, its rear legs digging into the surface for traction. The muscles inside its thorax begin to contract. Pennate pattern, feather-like pattern, high density of muscle fibers packed in a very small space. A short but mighty contraction serves as the engine for the operation. The force is then transferred through the body. The beetle's exoskeleton plays a crucial role. This outer shell is not just protective armor, it is a rigid, lightweight frame. Unlike our internal skeletons, where muscles pull on bones across flexible joints, the beetle's muscles pull on the inside of its rigid shell. The shell acts as an external lever system, multiplying the force and directing it with purpose. A design of profound efficiency. Power flows from muscle to horn. We can see the machine in action. The head lowers, the great horn slides beneath an obstacle. The legs are braced, the muscles contract. The entire body becomes a single, integrated lifting apparatus. The force travels from the thorax, through the rigid connection at its neck, and is focused into the tip of the horn. There is no wasted motion, no wobble or inefficiency. It is a pure, direct application of power. The beetle is a living machine, a perfect fusion of motor, chassis, and tool designed for a single purpose: to move the immovable. The most conspicuous feature of the male Hercules beetle is, of course, its horn. This magnificent structure, sometimes growing longer than the beetle's own body, is the focal point of its strength. A long, formidable horn projecting from the head. A shorter, thicker horn extending upwards from the thorax. When the beetle prepares to lift, these two parts close together like the jaws of a vice. They grip an object or a rival. The two horns close like a vice. Arrows show muscle force at the base and amplified lifting force at the tip. This dual horn structure is more than a weapon. It's a beautifully simple and effective lever. In its most basic form, a lever is a tool that allows you to multiply force. By applying effort at one end of a rigid bar, you can generate a much greater force at the other end. The Beetle's horn system works on precisely this principle. The powerful muscles in the beetle's thorax and head provide the effort. They pull on the base of the horns from inside the exoskeleton. This small but powerful movement is then magnified by the length of the horns. The longer the horn, the greater the mechanical advantage. Let us break it down into simple steps. First, the beetle positions itself, sliding the lower horn under its target. Second, it clamps down with the upper horn, securing its grip. Third, the powerful neck and thoracic muscles contract. This contraction pulls the head downwards. Because the horn is a rigid extension of the head, this downward pull at the base translates into a powerful upward lift at the tip. The beetle's entire body acts as the stable fulcrum, braced by its firmly planted legs. It is the same principle a person uses with a crowbar to lift a heavy stone. This design is a masterclass in efficiency. It allows the beetle to project its strength far beyond the immediate reach of its body. Pry, lift, flip. During territorial battles, this leverage is devastating. A well-positioned beetle can get its horn under its rival, and with a single powerful heave, send the competitor flying from the branch. The beetle's strength is not just a matter of muscle and leverage. It is deeply rooted in the very material and structure of its body. Its exoskeleton, the hard outer shell, is a marvel of natural engineering. It is not a simple, solid case. Instead, it is a complex, multi-layered composite material. The outermost layer is thin, waxy, and hard, providing a durable and water-resistant surface. Beneath this lies a much thicker layer made primarily of a substance called chitin, arranged in fibrous sheets. This is where the true architectural genius is found. These chitin fibers are not arranged randomly. They are laid down in successive layers, with the fibers in each layer oriented at a slight angle to the one below it. This cross-hatched helical structure is incredibly effective at distributing stress and resisting fracture. If a crack begins to form in one layer, its path is interrupted and redirected by the differently angled fibers of the next layer. This prevents catastrophic failure, allowing the shell to absorb significant impact and bending forces without shattering. It is both incredibly strong and surprisingly lightweight, a combination that engineers constantly strive to replicate. Furthermore, the overall shape of the exoskeleton is optimized for strength. It is a collection of curves, arches, and domes. These shapes are inherently strong because they distribute forces evenly across their entire surface, avoiding the concentration of stress at any single point. When the beetle lifts a heavy load, the force is channeled through these curved structures, spreading the strain throughout the thorax and abdomen. This prevents any one part of the body from buckling under the immense pressure, ensuring the entire frame works as a single cohesive unit to support the load. This combination of advanced material science and brilliant structural design means the beetle's body is more than just a container for its muscles. It is an active participant in the generation of force. It provides the rigid framework needed for the muscles to pull against and the unyielding structure required for the levers to work effectively. Without this incredibly strong yet light exoskeleton, the beetle's powerful muscles would be useless, their force dissipating without a solid anchor. The shell is the silent, essential partner to the beetle's brawn. While the horn captures our attention and the muscles provide the engine, the beetle's 6 legs are the unsung heroes of its incredible strength. Without them, all that power would be for naught. They are the anchors, the foundation upon which every feat of lifting is built. Each leg is a masterpiece of functional design, a chain of jointed segments providing mobility and unshakable stability. Each leg ends in a pair of sharp, curved claws known as tarsal claws. Why has evolution gifted this small creature with such disproportionate strength? The answer is tied to the fundamental drive of survival and reproduction. The beetle's power is a tool forged by competition. The stage, a tree trunk, a fallen log, where males gather to vie for females. Might makes right. Strength is the currency. Battles are epic, miniature duels. Contests of pure power and leverage. A male approaches a rival. They lock horns, pincers clamping. The pushing begins. Each beetle braces its legs, contracts powerful thoracic muscles, attempts to lift and dislodge the other. The goal, pry the opponent from the surface, toss him to the ground below. The loser climbs back up. The victor wins the right to mate. Intense competition equals strong selective pressure. Over generations, stronger males, more effective horns, more powerful muscles, succeeded more often. Females favor victorious males as signs of fitness. An evolutionary arms race pushes capabilities to the limit. Beyond combat, strength has practical daily uses. The rainforest floor is messy and obstacle-ridden. Push aside heavy debris. Burrow into rotting wood to find food. Burrow into rotting wood to lay eggs. Hold one's ground against the elements. The same power carves out a niche in a challenging environment. Strength is a versatile adaptation. Drama of courtship, quiet labor of foraging. As the beetle plants its feet, the claws dig into minute surface imperfections, the rough texture of bark, the fibers of a leaf, the grains of the soil. This gives a powerful grip, preventing the beetle from slipping backward as it pushes forward with immense force. The legs bolt the beetle to its environment, creating a stable base of operations. The leg joints play a critical role. They let the beetle adjust posture with minute precision, lowering its center of gravity to be more stable. By widening its stance and angling its legs, the beetle creates a broad, triangular base of support, much like a weightlifter planting their feet before a heavy lift. This posture directs force upwards into the load, not wasted in rocking or tipping its own body. Each leg acts as an adjustable strut, fine-tuning the beetle's connection to the world. The beetle distributes load across 6 legs, constantly shifting balance to counteract weight. As it lifts, it may push down harder with rear legs while the front legs guide and stabilize. This is not static, it is dynamic. The beetle makes tiny adjustments, its nervous system coordinating tension in each leg to maintain equilibrium. The legs are not passive supports, they are an active, intelligent suspension system, crucial for turning raw power into controlled, effective work. The Hercules beetle is more than just a biological curiosity. It is a living blueprint for advanced engineering. Scientists and designers in fields ranging from robotics, material science look to this tiny creature for inspiration. Its body is a testament to the power of efficient design, demonstrating how to achieve maximum performance with minimal material and energy. By studying the beetle, we can learn fundamental lessons about creating structures that are both incredibly strong and exceptionally lightweight. Roboticists are keenly interested in the beetle's mechanics. The design of miniature robots, especially those for navigating difficult terrain or performing delicate tasks, can benefit from the beetle. The way its legs grip surfaces, the efficiency of its lever-like horn, the integrated muscles and exoskeleton, each provides a model for creating more effective and robust machines. Imagine a search and rescue robot, small enough to crawl through rubble, built with the same principles of leverage and grip to clear debris. Materials scientists study the composition of the beetle's shell. The layered fibrous structure of its chitin exoskeleton offers insights into creating better composite materials. These bio-inspired materials could be used in everything from aerospace engineering to build lighter and stronger aircraft components, to protective gear like helmets, to body armor. The beetle's shell teaches us that the arrangement of materials is just as important as the materials themselves. Even the simple physics of the beetle's lift provides a valuable perspective. It reminds us that creative solutions often involve clever mechanics rather than just brute force. The beetle doesn't have bigger muscles in the way a human might. It has a better system for applying the force it has. It is a master of leverage and structural integrity. The Hercules beetle challenges us to think differently about how we solve engineering problems, encouraging elegant, efficient solutions that harness the laws of physics in clever ways, just as nature has done for millions of years. So we return to the quiet image we began with, a single beetle in the deep forest gloom. Its polished shell reflects a sliver of light. Its horn is poised, a dark silhouette against the leaves. And we remember the astonishing fact. This creature can lift 850 times its own weight. The number is no longer just an abstract statistic. It is a window into a world of profound complexity and elegance. A world where the laws of physics are manipulated with a mastery that rivals any human invention. The beetle's strength is a product of millions of years of refinement. It is a strength born from a perfect synthesis of form and function. The lightweight, durable architecture of the exoskeleton provides the frame. The densely packed muscles provide the engine. The ingenious horn provides the leverage. The gripping legs provide the anchor. No single part is the source of its power. Its power arises from the flawless integration of all parts working in concert. It is a holistic system, the whole greater than the sum of its parts. The beetle is a living, breathing machine of exquisite design. When we look upon the Hercules beetle, we should feel a sense of wonder. We are reminded that the most extraordinary things are not always the largest or the loudest. Awe lives in the intricate details and the silent, powerful mechanics of its movement. It prompts us to look more closely, to appreciate hidden genius in the small and the overlooked.